So yesterday what we did, we saw how to calculate or what is the application of the double integral to calculate the associated area. So how do we calculate this area? There are two methods. One is using the single integration. This method is using the single integration. And another method is using the double integration. So using double integration, suppose you are given the region A or the area A over which you wanted to calculate the area of the given surface. So what you do, you take the double integral of the function 1. So that means dx dy. And here should be the limits of x and here should be the limits of y. Or simply, I am writing this to be a. Whichever limit you wanted to take first, you can take it accordingly. It is up to you. So basically here we are writing the function f of xy as equal to 1. And using the single integration, what you are doing, you are taking the integration of the upper curve minus the lower curve. So the upper y value minus the lower y value into dx and the limits of x here. The lower limit and the upper limit, or the minimum or the maximum value you can say. So the minimum value and here the maximum value. So let us see one more question using where we have to calculate this area. So write down the question. The question is, find the area of the region. Find the area of the region bounded between the parabolas. Now two parabolas are given to you. Y square is equal to 4ax and x square is equal to 4ay, where this a is given to be positive. Now this is given to us. So the first step here is to visualize what is the given area. So for that, let us first draw the coordinate axis. So this is your x-axis, this is the y-axis. Okay, so what is our visualization of these two given parabolas? So firstly, we draw this parabola y square is equal to 4ax. So this is the right hand side parabola, right? So let's label this y square is equal to 4ax, and the other parabola, that is this point is origin, right? So the other parabola, this is the upward parabola. So it would be something like this, passing through origin. Okay, so this is x square is equal to 4ay. So now you have to find out what is the point of intersection. So you have to solve these two equations. So when you solve these two equations, you obtain 2 points. One point is x is equal to 0 and y is equal to 0. And the other point is x is equal to 4a and y is equal to 4a. So these are your points of intersection. So that means this point, what is this point? This is 4a comma 4a, and this point, this is 0 comma 0, that is the origin. So what is your shaded portion here, or what is the region where you wanted to calculate this area? So this is this particular region. So in this region, how can we calculate the area? We'll calculate the required area using the double integration. So using the double integration, the corresponding area of the shaded region, it would be equal to the integration of the function we are taking now to be equal to 1, because we are interested to calculate the associated area. Now it is up to you whether you wanted to take the limits of x first or the limits of y first. So in this case, suppose I take the limits of y first and then x. So that means what I will do, I will draw a vertical line here. So when you draw this vertical line, you see what is the value of y here and what is the value of y here. So in the first case, the value of y is simply x square by 4a, and due to this curve, right? And at this point, this is due to this curve, the value of y, that is equal to 4ax square root, right? So we obtain our lower and upper limits. So the value of y with the lower limit is x square by 4a, and the upper limit here is 2 square root ax. I have taken out this 4 outside this square root. And what are the limits of x? The minimum and maximum limit of x. Now within this region, your x is varying from here to here. What is the value of x here? 0, and the value of x here 4a. So that means your constant limits of x, they would be 0 to 4a. So these would be your limits. Now the next task is to integrate. Now integration is very simple. The integration of 1, that is y. So when you substitute the limits for y, y is equal to x square by 4a, and the upper limit as 2 square root ax, and here the integration is from 0 to 4a with respect to dx. So first of all, we'll substitute the limits. So it would be 2 square root ax minus x square by 4a into dx. The next task is to perform the integration with respect to x. So because this 2 square root a is constant, so the integration of x to the power 1 by 2, that is equal to x to the power 3 by 2 by 3 by 2, and the limits here are from 0 to 4a, and for the second quantity we have 1 by 4a constant outside, and the integration of x cube is x square is x cube by 3, and the limits of x are from 0 to 4a. So now we can simplify this. So it would simply be 4 by 3 square root a into 4a raised to power 3 by 2 minus 1 by this 12a, right? And here 4a raised to power 3. So when you solve all this and you simplify this, your final answer would be 16 upon 3a square. So this is your answer, and this is the required area of the bounded region. So similarly, you can very easily calculate this area even using the single integration, but it is better to learn and understand this double integration through this process, how to calculate the area using this double integration.